Hello, this is Mr. Escaton, and we are working on Module 7.3. We're going to be talking about using the distributive property to solve equations. All right, so here we have this equation. We have 5 times y minus 4 equals 7 times 2y plus 1. Now, we haven't seen anything like this before, but you guys did just get done, finished, kind of getting a refresher on how to do the distributive property. So the easiest thing that we want to do here is when you think about PEMDAS, the first thing that we need to do is parentheses. Got to get rid of the parentheses. In order to do that, I'm going to draw my arrows. I need to multiply on the left side of this equation, the 5 times the y, and then I'm going to multiply the 5 times the negative 4. On the right side of the equation, I have 7 times 2y, 7 times a positive 1. Now we're going to do one step at a time, one side of the equation at the time. So if I take 5 times y, I end up with 5y. Then I do 5 times negative 4. The most important thing to remember is we have to carry this negative sign. So 5 times negative 4 gives me negative 20. On the right-hand side, 7 times 2y gives me 14y, and 7 times 1 gives me, or a positive 1, gives me plus 7. All right. After we get to this point, guys, this should look pretty easy for you. This is nothing but solving an equation with variables on both sides, or a 3-step equation. You guys just got done learning about this. So I have a decision I have to make. I can either subtract 5y from both sides, or I can subtract 14y from both sides. I'm going to go ahead and subtract 5y from both sides because, again, I do not like my exponents to be negative. And now I'm going to clean it up. And on the left, I'm only left with negative 20. On the right, if I take 14 minus 5, that gives me 9y. And I haven't done anything with this plus 7, so that just comes right down here. Okay, again, I have my variable over here on the right side. That means I need to get all my numbers over here on the left side. So I'm going to do the opposite of adding 7, which is subtract 7. Do the same thing over here. And I'm going to take a look now. So I have same signs. I add the numbers, keep the signs. I end up with negative 27 on the left. And on the right, I end up with 9y. Guys, this is just a one-step equation now. What's happening with the y and the 9? It's being multiplied. The opposite of multiplication is division. I divide both sides by 9, and I get y equals a negative 3. So that's when we have distributive property on both sides of an equation. Now I want to take a look at a different type of equation that still uses the distributive property, but there's an extra step that you need to do. Okay, so this is out of page 210 in your 8th grade Go Math book. So we have 3 times x minus 5, and then outside of the parentheses, plus 1. That equals 2 plus x. Well, again, we think about PEMDAS. The first thing that we want to do is we got to use the distributive property. So I need to take this 3 times x, and I need to take 3 times negative 5 and get rid of those parentheses. Again, we're going to do one step at a time. So 3 times x gives me 3x. 3 times negative 5 gives me negative 15. I didn't do anything with this plus 1, so I'm going to bring it down. I also didn't do anything with the right side of this equation, so I'm just going to rewrite it. So now take a look at what we have right here. I have a negative 15 plus 1. How do we do that? Well, I showed you guys the system that we talked about when you started talking about equations with variables on both sides, where you would put a square around every term that had a variable and a circle around every term that did not. So that's what I want you guys to do here. So I'm going to go ahead, because I have to combine like terms, I'm going to go ahead and put a square around this. I'm going to put a circle around this. And this is also a term without a variable, so I circle that, square this. Now take a look at the left side of the equation. Anytime you have two circles, that means you can combine them. You can combine them together into one number. So again, ask yourselves, what is negative 15 plus 1? We have opposite signs, so I subtract the numbers. That gives me 14. I use the sign of the larger number. 15 is larger, so I'm going to make this a negative 14. I didn't do anything with the 3x, so I'm going to just bring it down. And then I'm going to bring down my 2 plus x. Again, now we are back to the point that this is an equation with variables on both sides. So what I want to do here is I want to remind you guys about the squares and circles. I'm going to put a square around this, circle around that, circle around this, and a square around this. And when I do that, I want to get all my circles on one side, my squares on the other. First thing I'm going to do here, I'm going to subtract x from both sides. Well, anytime there's not a number in front of the variable, I know that there is an invisible 1. So 3x minus x leaves us with 2x. I didn't do anything with that negative 14, and I also didn't do anything with this 2 over here. So we have the variables on the left side of our equation. We need to get this number right here all the way over here on the right side. So negative minus 14, the opposite of that is plus 14. Now I clean it up. I'm left with 2x on the left, 16 on the right. A one-step equation, I divide both sides by 2, and my final answer, x equals 8. This has been Module 7.3. This is Mr. Escaton. Thank you very much.